Hello, welcome. My name is again Sang-Hwa Lee. I'm the professor of Handong Global University at the School of Global Entrepreneurship and ICT. This is my third class out of the series of 14 classes about how to build business strategy. And today's topic is MECE and logic tree analysis. Okay, if you look at our previous class, in the first class, I talked about strategic thinking, and in my second class, I presented the overview of the problem-solving 7 steps. Okay, what is the strategic thinking? Okay, strategic thinking is different from intuitive thinking in that they rely judgment on the facts and objective evidences instead of the feelings, emotions based on the past experiences and prior knowledges. And strategic thinking has 4 elements: information seeking, analytical thinking, conceptual thinking, and leading and driving. And finally, I also emphasized that implementing the strategy is as important as building the strategies, right? And just in the previous class of problem-solving 7 steps, I presented the 7 problem-solving steps by McKinsey & Company, and then the first step of the problem-solving 7 step, which is defining the problem, is the most critical and important step in problem solving. And I also introduced the concept of the problem. Problem is a phenomenon or a situation in which the gap exists between the current state and the target state. And I emphasized that there are 2 functions in deciding the gap. One is the current state, and the second is the target state. I had 2 examples to explain what the problem is. One is engagement score of our company, which is quite low, which is lower than our comparable company. And the second one is our target earnings number is quite high, higher than the projected earnings number in 2 years. So the gap is the difference between the target earnings number and the expected earnings number. And finally, I showed the elements of good problem solving, good problem statement, which has 7 elements. One is the quantitative statement, explicitly stating about the problem, and the second one is background on or the context of the problems we want to solve. Third element is decision maker, who makes a decision about implementing the proposed solutions. And then the fourth element is key stakeholders involved in drawing the proposed solution. And number 5 is defining the criteria for determining whether the problem is solved or not. So that's called the criteria for success. And element number 6 is constraints within solution space. And finally, number 7 is in scope and out of scope of solution. So specifically mentioned about do's and don'ts during the problem solving process. And I used a case of the improving operating margin through the increase of the market share of major product X of our client. And as I said, I will use this case of improving operating margin throughout the series of building the business strategy for the remaining classes. Okay, that was the summary of my prior classes in number 1 and number 2, and this is the third class of the series of the business model building, and the topic of today is MECE and logic tree analysis. Okay, if you see that this slide, this is exactly the same as the slide you have seen in the previous class, but today's topic is on the second step of problem solving, disaggregating the issues. In disaggregating the issues, today's topic of MECE and logic tree are very powerful tool in these aggregations. So in conducting the second stage of the problem solving, the tools we will use, the useful tools are MECE and logic tree, and I just want to introduce those two tools, which is quite useful in step number 2. In disaggregating the issues, the concept of MECE, M-E-C-E, is useful tool. MECE means, MECE is divided into me and C. MECE is divided into ME and CE. M stands for mutually, and E stands for exclusive. C stands for collectively, and E stands for exhaustive. So MECE means mutually exclusive. So when we disaggregate the issues, the divided issues should be mutually exclusive. That means there should be no overlaps between the two disaggregated issues. And CE means collectively exhaustive. That means there should be nothing left uncovered out of the entire issues. So all the sub-issues, all the disaggregated issues may compose of the entire issues we want to address. So there is nothing left uncovered. Okay, let me show you some of the examples of MECE and not MECEs in order for you to understand MECE, the concept of the MECE a little bit more. If you see left-hand boxes A, B, C, between A and B, or between B and C, or between A and C, nothing is overlapped. Okay? So in that sense, A, B, and C is mutually exclusive because there is nothing overlapping, right? Also, if we combine the area of A, B, and C, that is composed of the entire box. So nothing is left without being a part of A, B, or C. Okay, so that's MECE. So when disaggregating the problem of the entire box, which can be divided into either A, B, or C. So if we analyze the small issue of A or B or C, we can address the entire problems. So that means that is collectively exhaustive, and also nothing is overlapping if we just address A, B, or C. If you see the on your center of this slide, there are 3 boxes, which each of them is not MECE. Okay, if you see the upper box of not MECE case, which is the whole box is about living things, living creatures, about living mankind and anything. And if we say that the small circle of A is mammals, and big circle of B is fish, if we divide the entire box into those 2 small boxes, A and B, mammals and fishes are addressed in our analysis. But there are a lot of things uncovered still outside both A and B circles, but still inside the boxes, right? For example, the birds flying in the sky, that is not mammal. Also, the birds are not fish. So if we only address and analyze the circle of mammal and fish, still a big portion of the living creatures, which is birds, is not covered in our analysis at all. So in that sense, dividing the entire boxes into A and B is not collectively exhaustive, right? But circle A, mammal, and circle B, fish, is not overlapping each other. There's no creature included both in mammal and fish, right? So in that sense, A and B are mutually exclusive because there is no overlapping at all. So this is a small example of the understanding the MECE, okay? A and B, mammal and fish, is mutually exclusive but not collectively exhaustive in addressing the entire living creatures. Let's have a look at the center box. The entire box is women. Left-hand box of the center women box is not married women, and right-hand box B is married women. Okay, A and B is mutually exclusive, right? There is no women who belongs to not married and married at the same time, right? There's only one choice between whether she belongs to not married women or married women circle, married women box. So in that sense, A and B is mutually exclusive because there is no overlapping. Okay? And also, if we divide the entire box of the women into not married women and married women, there is nothing left uncovered. So in that sense, A and B is collectively exhaustive. But the problem is the circle C. Circle C is the career women. If we divide the entire women into 3 categories, one is not married women, B is married women, C is career women. Even though A and B is mutually exclusive and collectively exhaustive each other, A and C is not mutually exclusive and also collectively exhaustive, because there are some career women who are not married. In that case, that belongs to A and at the same time C. So that's highlighted as the overlapping areas. So A and C is not mutually exclusive. And also, if we analyze the circle of A and C, still there are the people who are not career women and at the same time they who are married. Okay. So even though we analyze a lot of things, we divide the entire women to A, B, and C. A, B, and C comprises of the entire women. So in that sense, A, B, C are collectively exhaustive, but there is some overlappings because of the C between A and C, and also between B and C. So ABC is not mutually exclusive. Okay. Let's have a look at the bottom box of the center line. The whole box is the whole classmates in your class. Maybe there are 30 students in one class. So the whole box is about whole classmates. And circle A on inside this box is about students who are good at math. And circle B is students who are good at English. In that case, there's some overlapping areas which addresses the students who are good at both math and English. So in that sense, A and B is not mutually exclusive because there is some overlapping areas. And also, there are the students in the whole classes who are not good at math and who are at the same time are not good at English either. So in that sense, if we divide the entire classmates into A and B, there are still the students who are left uncovered. So in that sense, this is not collectively exhaustive. Okay? So simply, I used a couple of the examples for you to help you understand the concept of MECE. Why do we learn about the tool of the concept of the MECE? Because in disaggregating the issues, it's better for us to disaggregate our sophisticated problems into the sub-issues as MECE as possible. Otherwise, we are still missing important issues uncovered if we do not apply the MECE rule, because it's not collectively exhaustive. And also, if there is something not mutually exclusive, if there is some overlappings between two sub-issues, and it makes more complicated, and there's no benefit of disaggregating the issues into small issues, right? So that's why I emphasize you to use the the concept of the MECE in disaggregating the problem into small issues.